Hey guys, today I want to talk to you about molarity. And so we have been dealing with stoichiometry and limiting reactants. And with stoich, we've gone grams to grams. So grams to moles, moles to moles, moles to grams. And that's pretty common to do that. If you have a mass of something, how many grams of something would you get? We've gone mole to mole, which we've looked at the ratio. But what we haven't really talked about yet is what you've actually done in the lab. Think about when you guys put the copper wire in the silver nitrate solution and we saw all these silver particles being formed. And everybody's always asking, hey, could we get that out of there and sell it? You could, but if you do the stoich, you'd find out it's not worth it. It's not going to make you enough money. It's going to actually lose money in the process to do that. So what we haven't looked at yet is what happens when you're dealing with a solution. Because for a solution, you don't know how many grams you have in the sample that you take. We can't just put it on a balance and go, oh, I have this many grams. You have a solution. So what we have to do is figure out, how do solutions work when we do stoich? And so that's what I'm going to show you today. This simulation here on my computer is what's called a PhET simulation, and it is also up on PowerSchool if you need to go play with this more than just what I'm going to show you right now. So if we look at this, it gives us a drink mix, so like Kool-Aid. And it tells us that we have solute, which is the amount of moles, and we have solution and volume, and then we have solution concentration. So right now might not be a bad time to write in your notes that your solute is what is being dissolved. It is the substance being dissolved. So if you think about Kool-Aid, you're dissolving sugar and Kool-Aid mix. Those are your solutes, okay? Your solvent is what is doing the dissolving. So in all the examples I'm going to show you today, it's water. Those aqueous solutions, it's going to be water. Now, what they're showing us here is what is the volume of the whole solution. So when you add the solute and you add your water and you stir it up, what is our volume in liters of this whole solution? So this is going to give us how concentrated this is. So our Kool-Aid mix right now has 0.50 moles and 0.50 liters. And it tells us over here that we have a molarity of 1. Well, what if I decide to add a whole bunch more Kool-Aid mix? So I'm going to crank it up to 1. Notice that our solution or our Kool-Aid mix got a lot darker because it's more concentrated. You put more solute in the same volume. So notice our concentration went up to 2, okay? Well, what if I decide to crank up the volume? I'm going to add more water to this now. Notice 1 mole, 1 liter, we're back to 1 molar. If you have not noticed the relationship right now, it's moles per liter gives us molarity. So if I crank this down and I have 1 over 0.2, 1 divided by 0.2 is 5 molar. So all molarity is moles per liter. Moles per liter equals molarity. Now molarity is a capital M. Science gets weird and there's a lot of M's. So you're going to have to give yourself a reminder that the big M is molarity and little m is actually molality, which we'll get into here in another week. Okay? All right, so I'm going to change this to something else. I'm going to go with gold. All right, I'm going to reset the gold and I'm going to show you some stuff. All right, so right now we're at 1 molar of gold chloride. So I'm going to add some solute. I keep adding. Notice your concentration's going up. So the more solute you have per volume, the stronger concentration is, or higher. And then we keep going. We're good. Okay, so 2 molar. What if I drop the volume? Ask yourself, what do you think is going to happen to the concentration if I drop the volume? So maybe I evaporate out some of the water. It went up. Is that what you expected? If you think about it being moles of solute per the liters, if you decrease the amount of that solution, yeah, it would be more concentrated. It's like you taking out some of that water from your Kool-Aid or your hot chocolate. It's going to get a lot stronger. One thing I want you to notice, as I do this, notice I get to right there and I get something called saturated. Saturated is the point at which you have filled up all those available spaces and you're not able to take any more. It's going to settle out into solids. So you have saturated that solution and it cannot hold any more solute at all. So if we drop this down, that's really saturated and you're seeing particles settle out.